In this video, I'd like to talk about extending arithmetic sequences. So we're going to look at several different example problems where we'll be given an arithmetic sequence and we need to figure out what the next term is. So remember with these arithmetic sequences that these are additive. Whereas if we had a geometric sequence, then going from one term to the next, we would be multiplying. So in these, notice that you're adding the same number to each of these terms to find the next one. And we call that number that we're adding from one term to the next the common difference. And in this case, the common difference is 2. So every term going from 1 to 3, we add 2, from 3 to 5, we add 2, and so on. That pattern continues. And so to find that next term, we just need to continue it. We're going to add 2 to 9, and we would get 11. So 11 would be our final answer here, and if they asked for another term after that, it'd be 13, then 15, and so on. So the main goal of these problems is to find that common difference and then apply that pattern to be able to find that next term. So now let's look at several more examples. So for this next one, we need to find the next term of the sequence, and this one is actually counting down. So in this case, again, we're looking for that common difference, essentially the pattern, but what's different about this one is that we're actually subtracting from one term to the next. Or you could think of it that we're adding a negative number from one term to the next. And so going from 7 to 5, we are subtracting 2. And going from 5 to 3, we subtract 2 again. And so our common difference here, we are subtracting 2 from one term to the next. And so to find that next term, we're going to take 3 and subtract 2, and that will give us 1. Of course, we could keep going. If we want to find the next term, we take 1 and subtract 2 again to get negative 1, and we could keep going to minus 3, minus 5, and so on. So let's keep going with these. We'll look at 2 more problems. In this one, we'll actually start in the negatives, but the process is still the same. We just need to figure out that common difference. For this, I'll just label it as CD. So what are we adding or subtracting going from one term to the next? And since we're going more negative, we are going down essentially, or we're subtracting. So if you take minus 2 and you subtract 2, you will get minus 4. If you subtract 2 again, you get minus 6. If we were counting up, we would be adding. So our common difference in this case, we are subtracting 2. So to get that next term, we take minus 6, subtract 2 from that, and so minus 8 would be our final answer, though we could, of course, continue this to keep finding the next terms in the sequence. So let's do one last problem. And again, we're starting in the negatives, and it looks like it's a bigger gap from one to the next in this one. So we need our common difference again. So going from one term to the next, what are we subtracting by? Since we're going more negative, we know we're subtracting. If we were heading towards the positives and counting up, we know we'd be adding. So to go from minus 8 to minus 14, it looks like we subtract 6. From minus 14 to minus 20, we subtract 6. And we continue that pattern. And since the pattern is the same between any two terms, if you're having trouble maybe figuring out what it is here, or you're not confident, maybe choose 2 easier terms to look at that common difference. Since maybe it's more obvious going from minus 20 to minus 26 that we are subtracting 6. So we'll extend the pattern once more, and minus 26 minus 6 brings us to minus 32. And if we wanted, we could find the next terms as well, but this will go on forever. So in this case, our common difference is subtract 6, or minus 6.